we have a lot of vocabulary that we're going to be putting in at the beginning of this unit. So what I'd like you to do is go to your vocabulary notebooks that you had before, and they should be alphabetical parts, and that's where we're going to be putting that vocabulary in. So if you can find that, if you need to pause the video, go ahead. And then I'm going to start. We're going to start with coordinate grid, so with the letter C. And our coordinate grid is going to be that a picture of a graph. And on that graph, we have 4 quadrants. So this is our quadrant 1. They're usually done with Roman numerals. Quadrant 3 and quadrant 4. And then remember that this is our x values here are positive. Oops, I just put x instead of positive. Our x values are positive and our y values are positive. When we graph our points, we're always graphing x comma y, and which is really telling us that we're going to be graphing going over first and then either up or down. They mean the same kind of thing there. Our second coordinate, our x values are negative and our y values are positive. In our third quadrant, they're both negative. In our fourth quadrant, didn't necessarily need the 1, just wanted to have a negative in there. And then in the fourth quadrant over here, we have x's are positive and y's would be negative. So wherever point I have, I would put those in there. And this middle point here, I'm going to put that in as a different color. This point here is our 0, 0, which is going to lead us to our next word, which is the origin. And it is the point 0, 0. It's where the x and y axis meet. Our next word is going to be, let's go to x and do x-axis. So x-axis is the horizontal number line on a graph. And then remember that horizontal means that it's going this direction here. And we'll do y-axis next. Y-axis would be the vertical number line on a graph. So we have our x-axis, our y-axis. We also have independent and dependent variables. So you're going to flip to the letter I. We're going to do independent variable first. Independent variable goes on the x-axis. Oftentimes, it's kind of the part that could stand alone, the piece that can stand alone. Such as time, because time would continue even if we're not doing anything. It's what we have chosen the intervals for. So if we say we're going to mark something every 10 seconds or every hour, we've chosen that. So a lot of times that's our independent variables. So it's often the part that we control. And by control, we're not saying we actually control time. And we would say like time intervals would be something, or again, we can't control time, but we can control that interval type piece. Our next one is going to be the dependent variable. It goes on the y-axis. And it's going to depend on the independent variable. The number of people at a beach is going to depend on the temperature. So temperature would be the independent variable. The warmer it is, the more people that are at the beach. The dependent variable, again, would be the number of people going there. It could be the same thing with like every 10 seconds, the distance that you walk away from home. So how far you walk depends on how long you've been walking. And so again, we can kind of look at it as what depends on the other one. And you can often look at it as two different ways. Does the number of people at the beach depend on temperature, or does the temperature depend on the number of people at the beach? But because we could have 50 people show up to the beach, or even 1,000 people, unfortunately, it's not going to make it warmer in the winter. That temperature is still going to be what it is, and most likely, hopefully, nobody's going to be at the beach for swimming. And you can always ask me the funny story about my twins and the beach. Our last word is going to be scale. So scale is the even amount each axis goes up by, which is going to be either the x or the y. So the even amount each axis goes up by. So we could have things going up by ones, which would mean that if I had my x-axis here, it's going to go 1, 2, 3, 4. We could go up by 2's, which again would go up by 2, 4, 6, 8. Sometimes we do 3's, but often we'd end up going up by 5's or 10's at this point if we start getting bigger numbers. You just want to make sure that you're not scrunching your graph too much, where you can't really see much, that it just fills a really tiny piece. Spread it out for the graph that I give you. This amount here, when I'm looking on these pieces here, these have to be the same. So in order for our graph to go up evenly, we need that axis to be the same. So this has to be the same. It can't just go up by the numbers of your table. It has to, we have to look and say, how much do I go up by? And then I would have both my x and y axis can have a scale. Those two scales don't have to be the same. So if I have a graph here, I can have the bottom part going up by 1's. And maybe this is going to be hours because we should label them. And I can have this graph going up by 20's. Or 10, sorry. I just said 20 because I was writing a 20. And maybe this is going to be miles biked. And maybe we're doing a biking trip. So we need a title. So in this case, how many miles that we bike would depend on hours. So our hours is our independent variable. Miles biked is our dependent variable. My scale on this x-axis, so scale of x-axis is 1. And the scale of y-axis equals 10. So again, they don't have to be the same. They can be the same, but they don't have to, as long as each axis goes up by the same amount every single time. All of these should be in your vocabulary section. You will be using these throughout this unit, so make sure that you have them in a place where you can also reference them.